So here the rate of this person is 1/20th of a job per day. So that's the fraction of the job they're doing in one day. So on day 1, they've completed 1/20th of a job. Now on day 2, he's joined by another person, so their rate is doubled. So they will do this fraction of a job. And then day 3 would be another person, so the rate would be 3 times. They would do 3/20. And then day 4 is 4/120. And so you can see the question is how many days are required. So if, let's say, day n, they would do n/120th of a job. So if I were to add these all up, the condition is that should equal to 1, because this is the fraction of the work they're doing. Once we get to 1, we've completed our job. So we'll see if we get to a exact whole number. So that's a consideration. n/120 equal to 1. So you'll see the numerator is just the sum of the first n natural numbers. So that becomes n plus 1 over 2, and then we have the 120. So here we can kind of guess the values here. This is 240. So if this is 10, oh no, that's not going to work. So this is 20, 21. Yeah, that's getting better. So if n is 20, this is, no, actually that's way too much, 420. So it has to be between 10 and 20. So if it's 15 times 16, so I'll just actually use the calculator here. 15 times 16. Oh, that works out. I guess I got lucky. So n is equal to 15, and that's the answer. The reason I was unsure here, because they've given these questions where maybe you need one more day to kind of exceed, meaning the sum is slightly less than 1. So n, you have to go 1 more. So I've seen those questions as well, but here it's 15. I could have done the quadratic, which really, again, boils down to looking at the products of those two. And I guess you had to kind of see this. I didn't see it immediately. So my fallback would have been just doing the quadratic. But of course, I think it's easier to solve these types of questions where they are really products of consecutive integers. It's easier to kind of guess the numbers by using a calculator. So the answer is 15.